This video is on Unit 2, Chapter 6 on Quadratics Extras, Lesson number 3, Writing Quadratics from Zeros. In the notes here under Writing Quadratics from Zeros, the first bullet says you will use the roots, zeros, or solutions to work backwards to find the original quadratic equation. Remember that your roots or zeros are what x is equal to. So those are those points where the parabola actually hit the x-axis. Factors are the binomials that multiply to create the quadratic equations. And then lastly, it says irrational roots and imaginary roots come in pairs. So the things that have radicals, the roots that have I don't come alone. One's always positive and the other one's always negative. So they come in pairs, and that's very important that you remember that. The steps are here stated to do this process. Step number 1 says to set x equal to each root. Secondly, if the root is a fraction, we want to multiply the equation by the denominator. Thirdly, use opposite operations to get a 0 on one side. These are your factors. So again, we start with the roots, what x is actually equal to, and then we use opposite operations to change those roots into the factors so that we can, in step 4, multiply those factors together, and then lastly, write the function notation. So let's look at the directions here for these examples. The directions tell us that the roots of a quadratic function are given. Write an equation that could represent the quadratic. In example number 1, we're given the two roots, 5 and negative 8. So again, that is exactly what x is equal to. X is equal to a 5 and x is equal to negative 8. Those are your roots, your zeros, your solutions. We're going to take those roots and turn them into factors by getting a 0 on one side. So for x equals 5, we're going to subtract 5, and I will show this to you just once. So we get x minus 5 equals 0. For x equals negative 8, we're going to use opposite operations and add 8 to both sides, and we get x plus 8 equals 0. So I've just turned those into the two factors. We're going to take those two factors, which are x minus 5 and x plus 8, and we're going to multiply them together to come up with the quadratic equation. So foiling this out, x times x is x squared. X times 8 is a positive 8x. Negative 5 times x is negative 5x. And negative 5 times 8 is a negative 40. And then I'm going to combine my like terms in the middle. 8x minus 5x is a positive 3x. Bring down that minus 40. Now, to make this function notation, you're just going to put an f of x out front. If you want to put a y, I'm okay with that as well. So either one of those is okay. I'll even take a 0 equals x squared plus 3x minus 40. So all of those are the same answer. They're the same quadratic that gives you the two solutions, 5 and negative 8. In number 2, we've got fractions. So I'm especially anxious to see how y'all do with the fractions. The steps that are listed in the notes are exactly what we need to do. Again, our roots are 1/2 and 4/5. So that's what x is equal to. Set equal, x equal to those roots. Now, as much as you guys hate fractions, you would think that the very first thing that you would focus on is trying to get rid of that fraction, which is exactly what you should do. For x equals 1/2, the denominator is 2. So if we multiply both sides by 2, we get 2x equals. The 2's are actually going to cancel each other out, and we're just left with the numerator of 1. Now, using your opposite operations, you want to subtract that 1, and we get 2x minus 1 equals 0. We're going to do that same process for x equals 4/5. The denominator is 5, so I'm going to multiply by 5 on both sides of my equation. And I get 5x equals 4. Now subtract that 4, and you get 5x minus, not a 5, 4. 4 equals 0. Now that you have your two factors, you're going to take the 2x minus 1 times the 5x minus 4, foiling those out. 2x times 5x is 10x squared. 2x times negative 4 is negative 8x. Negative 1 times 5x is negative 5x. Negative 1 times negative 4 is a positive 4. Combine your like terms. Negative 8x minus 5x is negative 13x. And I'm going to put an f of x out front. And there's my function notation. Let's look at example number 4. In example number 4, we've got radical 2. Now, in the notes, it made a comment, it made a statement in the notes about irrational and imaginary solutions coming in pairs. So that is not just a radical 2, it is a positive and a negative radical 2. So we're going to take both of those. X equals the positive radical 2, x equals the negative radical 2. And again, using your opposite operations, you're going to get your 0. So subtract the radical 2 on the first one and add the radical 2 on the second one. Now we've made them factors. So we're going to take those factors and multiply them together. X times x is x squared. X times a positive radical 2 is x radical 2. The negative radical 2 times a positive x is negative x radical 2. And then lastly, we've got negative radical 2 times a positive radical 2, which is negative 2. Remember that when you take a radical times itself, the radical sign goes away and you're left with just the number. For your like terms in the middle, they are opposites and they are going to subtract out, leaving us with just x squared minus 2 for our solution. And in example number 5, we've got 4i. Again, that is not just a 4i, it is a positive 4i and a negative 4i. So those are my two roots. We're going to take those and set x equal to each, the positive and the negative. Again, using opposite operations, we're going to get our 0. So on this first one, I'm going to subtract the 4i. On the second one, I'm going to add. And then I'm going to FOIL those two things together. Now, I'm not sure you're paying attention here, but these are actually conjugates. X minus 4i and an x plus 4i are conjugates, and the i's should go away. Now, I don't know if you noticed back up in example number 4, the x minus radical 2 and the x plus radical 2 are kind of the same thing. They're identical on the inside except for the plus and minus, and those two middle terms subtracted out. The same thing's going to happen here with our i's. X times x is x squared. X times a positive 4i would be a positive 4xi. The next one, negative 4i times x will be a negative 4xi. And then for the last one, negative 4i times a positive 4i is negative 16i squared. And you've heard me say it before, as soon as I see the I squared, I register in my head that that's negative 1. I squared is equal to negative 1, and negative 1 times negative 16 is going to make this term become a plus 16. So the I goes away. You'll notice that those two middle terms are going to subtract out. So we're left with x squared plus 16 for our solution here. Again, that is the quadratic function that has the roots of 4i and a negative 4i. I'm going to show you one of these, 6 or 7. Let's do number 6. But they are very similar in how you work these. So notice that it says 2 minus radical 3. Again, that is not just a 2 minus radical 3. It is a positive and a negative in the middle of that, but that's a binomial. We're still going to take x equal each of those a lot of students will make a mistake here, and they won't keep it as a binomial. They'll put the 2 and the radical 3 together, so just be careful. We're going to get a 0. I'm going to subtract the 2 and subtract the radical 3. So subtract the 2, subtract the radical 3 to get the 0. And on the second one, I'm going to subtract the 2 but add the radical 3 to get the 0. Now what happens is we end up with a trinomial times a trinomial, which is going to take us a little bit longer. I just forgot my minus. And then the x minus 2 plus radical 3. So this is not FOIL. This is distributive property. X times x is x squared. X times negative 2 is a negative 2x. X times a positive radical 3 is an x radical 3. So those are the first 3 terms. Now let's take the negative 2. Negative 2 times x is negative 2x. Negative 2 times negative 2 is a positive 4. And negative 2 times a positive radical 3 is a negative 2 radical 3. And then lastly, we're going to take our negative radical 3 times each of those. Negative radical 3 times x is a negative x radical 3. Negative radical 3 times a negative 2 is a positive 2 radical 3. And then negative radical 3 times a positive radical 3 is a negative 3. So there should be a lot of things that go away here. Your negative 2 radical 3 and your positive 2 radical 3 subtract out. Your negative x radical 3 and your positive x radical 3 subtract out. So once again, the radicals should go away here. Combining our like terms, we get x squared, negative 2x, and another negative 2x is a negative 4x. And then 4 minus 3 is a positive 1. So I'm going to put an f of x out front, and there is the quadratic function that has the 2 roots, 2 plus or minus radical 3. So there are your notes for chapter 6, lesson number 3 on writing quadratics from zeros.